In this last demo, I'll demonstrate how you can accelerate and decelerate your geared stepper motor's rotational speed. We'll use the same connections as in demo 3. In the sketch, we're replacing the stepper library with Accel Stepper, which you can download and copy into your IDE's libraries folder. Accel Stepper is a significant improvement over the default stepper library and allows you functions like acceleration and deceleration, multiple stepper motors, greater variety of stepper motor configurations, very low speeds, and various other programming type improvements. It's got great documentation as well. In this last demo, I'll show you how you can have a bit better amount of control of your motor by using an alternative library called Accel Stepper, also a very popular library. This is its website, SbS.com, and just looking at that documentation, you can see that it's quite a lot of very interesting features compared to the basic stepper library. So I'm going to be showing you of how to do acceleration and deceleration of the motor, but you can also have lots of stepper motors running at the same time, and it also gives you the ability to not block other functions running on your Arduino while the motor is running. More about this a little bit later. It supports different kinds of stepper motors. Look at the documentation here. I think it's pretty well documented. That provides you different types of interfaces to the motors, so how many wires they have, etc. Lots of different functions. So you can see, for example, there's a move to function. Takes in a long, it's a number that describes a position that you'd like the motor to move to. You can set the speed, the maximum speed or a rate of acceleration. You can also check to see how much further the motor has before it reaches the destination that you set up in the move to function, so there's distance to go. You can query this, to check if the motor has reached the destination that you set for it. Pretty interesting functionality overall. So download this library. Here's the link. It's version 1.41 at the moment, so download that, extract the archive and put it in the libraries folder of your Arduino installation. So I will upload it first to make sure it works and then go through the sketch together. Okay, so accelerating one direction, just full revolution, and now decelerating before it stops at the position where it began, then going back the other way. It accelerates, looks like it's doing 2 full revolutions on the way back. Yep. So the first turn was done in the setup function, and it involved a single revolution, and then from then onwards, inside the loop, we've got 2 revolutions each time. Okay, so how does this happen? Let's have a look. So first we include the Accel Stepper library. We set the number of wires that this motor is using, so 4. We're going to use that in a minute in the constructor. And we set the pins where the motor is connected, and here is the constructor. We'll create a new object called stepper1, so type Accel Stepper. We're telling the constructor how many wires we're using, so that the library can determine what kind of motor we're using, and then where we are connected to. In the setup function, we've got we set the maximum speed. Again, this is a number that you can play around with. As always, determine that 1000 is an appropriate maximum speed for my motor, and this is the acceleration rate. So 50 is just a number that says how quickly should the motor do its next step. So 50 is just a rate of acceleration. Set speed tells the motor what should be its first speed when it starts moving. So instead of starting at 0, which I could have done, I'm going to get its first speed to be 200, and then move to this position, which happens to be a full revolution, 48 times 64, because of the ratio of the gears. So inside the setup function, the motor is going to move 1 full revolution. Now inside the loop, I'm constantly checking how much longer the motor has to move until it reaches its destination. So once it does reach its destination, we're just going to tell it to move to the same position but the opposite way. So minus stepper 1 dot current position. It's going to move back. So the run function, this one here, is where we actually tell the stepper motor to move ahead by 1 step. You can see that the stepper.run call is inside the loop. So we could have other things happening inside the loop, like checking out sensors and communicating with web services and things of that sort. Eventually, once all those things are done, we would ask the motor to move to its next position, because the motor remembers where it needs to go and how far it's gone so far and all the other parameters of its movement, and then by saying run, it will just move to its next step, its next position until it gets there. So this means that we can do other things with our Arduino while a motor is running. It's not blocking other functionality. So that's about it. At this point, you should have a good understanding of what stepper motors are, why use them, and how to use them. As with anything, there's a lot more to learn, so I have provided some external references in the notes.